Hi, my name is Alessandra Desiree, and I'm going to present you my Mariotte bottle experiment. As we know, the Mariotte bottle is a device that seeks to capture the way water moves through an orifice under the effects of atmospheric and/or gravitational pressure. It follows the behavior indicated by Torricelli's principle, which determines the fluid exit velocity to be equal to the height from the liquid's free surface to the end of the orifice. In the first part of the experiment, the vent tube was placed just barely submerged in water, and the objective was to observe a constant water flow. Here we can observe that when the water reaches the end of the PVC, the speed begins to decrease due to the change in the effect that the pressure has on it. The initial hypothesis is that by having so much presence of atmospheric pressure, the water will descend faster. In the second attempt, we made a change in the height of the tube, submerging it halfway. Here you can see that the exit velocity no longer changes so drastically as quickly. This happens because it's prolonged by the height of the tube. As you might know, air needs to enter the container to replace the volume of the liquid leaving. This means that it should maintain a constant pressure inside the container and then causing that bubbles come out from the Mariotte bottle. However, there are no bubbles observed during this experiment, and you could see it in the recordings. And this could indicate that there is a leak in the lid that the container allows the air to enter without forming bubbles in the liquid. This means that the pressure inside the container does not remain constant as it should, which at the end could cause that the experiment has little accuracy defects. Actually, during our last attempt where the end of the tube is aligned with the hole was when we realized that was something not working as it should, since when we noticed that the water flowed in the same way as the other two attempts, even though they were aligned differently, we noticed that the speed should have been 0 because there is no height of water created to pressure. There was a leak in the lid. In the end, the initial hypothesis was partially approved, since the behavior was predicted thanks to Torricelli's principle. However, the objective was not achieved due to the error with the leak. As our final results, we have the next statements. In try number 1, it has a great speed because there is more height of water pressing down. Then in try number 2, it has lower speed since the height of the water is lower and therefore there is less pressure. And finally, in try number 3, it's supposed to have no exit velocity because there is no water height to create pressure.